Thank you, Georgina, for the lovely introduction. You've now ruined 3 of my slides. Yeah, just pictures of me. I just saw a Pikachu go past outside, so please don't leave if you're playing Pokemon Go. I'm going to give a quick talk on SQLite and query analysis. It's not a particularly deep or heavy talk on SQLite or query analysis, so don't worry. It was just something I happened to stumble across the other day, and I thought it might be a useful 5-minute talk to give. If you've ever done any SQLite stuff before, this may not be new to you. If you've ever done any kind of back-end Java J2E work and have used things like Hibernate and Oracle and stuff, this definitely won't be new, but it might be something that you've not done on Android before. So some questions for you rather than questions for me. Hands up, who has used SQLite in one of their applications? Good numbers, excellent. Who has used SQLite to store some locations that are later stored on a map or shown on a map? Some Google Map pins in a database. Okay, a few less people. And who used indexes on their SQLite database to improve the performance of those queries? Excellent, the same number of people. Good, my talk is now redundant. Okay, so I'm going to give you a quick demo of some code that I wrote in a 1-page simple app to go through some of the topics that I'm going to then talk about on the subsequent slides, so bear with me a second. Okay, hopefully you should be able to read all that. This is basically my database helper class in my sample application. The application itself has only got 2 buttons. One's going to run a particular query, and the other one's going to run some query with analysis. So let's go to the app. Hopefully this will work. And it's not frozen on me, as the emulator likes to do when you go into multi-screen mode. There we go. Oh, yeah. That is not looking funky, is it? Always prepare your demos on the screens that you're giving them on. Let me try running that again. How do I get out of presentation mode? Oh, there you go. So whilst that's starting up in the background, so I've got, here we go. It might not be too slow. Excellent, can't launch the emulator. Brilliant. This is going to be a really boring demo. Please. All right. So here is my dummy app. Hopefully you can see that at the back. It's got 2 buttons. One is going to run the query that is a particularly boring query, and then one's going to run it with some analysis attached to it. The database that I've pre-populated has only got 200,000 rows, and it's just got some fake names and some latitude and longitude values in there. Now, you're going to see some kind of millisecond query execution times displayed on the screen here. Ignore the fact that after I apply the indexes, it gets slower. That's a different topic for a different story. But the idea, the code is good. It's just that the results are bad. So
Worked on my machine.
Exactly, it worked before. So we're going to run this query. It's going to be pretty boring. I'm going to go through the 200,000 rows. I'm going to get back, based on my random query, some rows, 48,000 rows there, and it's going to take 147 milliseconds to do that. If we run the same query, which I'll hopefully show you in a bit bigger in a second. This is the main part here. So at the moment, we don't have any indexes on the table, and when we analyze the query that we're running against the SQLite database, you can see the analysis says it's going to scan the table, which basically means it's going to go and hit every single row in that 200,000 SQLite database to find the results for that particular query. If I can increase the font size on this without going into presentation mode. Can you read that query at the back in the green, or is that not readable at the back? It's kind of okay? Not really? Okay, I'll make it bigger. We're going to presentation mode. Is that better? Easier to read? Excellent, good. Okay, so the query that I'm running there is this SQL statement. So I've generated some random latitude and longitudes around the world, and I'm just asking for some that are between the minus 45 and plus 45 latitude and minus 90, plus 90 longitude. So just a big chunk of the Earth in the middle there. And we count the number of rows, and we measure the rough execution time to bring back the first row from the database cursor. Now, the analysis, which is the interesting bit, we run the same query again, but we have the explain query plan keywords ahead of the query. So it's going to analyze how the query is going to be run against the database, and that was where we saw the bit that says it's going to scan the entire database table to satisfy that query. So to see some improvements, although there won't actually be improvements, to see some improvements, what we're going to do is we're going to upgrade the version of our database, and when we do that upgrade, we're going to create an index. So I'm just going to make a small code change here. Hit save. Run the new version of my app. So again, hopefully you've not memorized how many milliseconds it took the first time. We run the query. We should see the exact same number of records being returned, 48,000. It's slightly slower this time. But when we run the analysis of the query, now that we've got an index on that database table, what you'll see here is the analysis returns. It might be a little small, sorry, if it is hard to read at the back. It says it's going to search the table using index example1. That's going to be an index on the latitude column only. And I'm going to explain why it's only on the latitude column in just a second. So you can see now that having applied an index to the database table, it's now going to use that index. Now, this may be something that you kind of just blindly add an index thinking, I know, I've done SQL before, I'll add an index to the table. But this here, you can actually see, if you analyze the query, you know for sure that the index is actually being used. So rather than just looking at the timing of those queries, which could be dependent on, is the device doing something else in the background? Is the emulator under load based on your laptop doing something in the background? Rather than just relying on the milliseconds for your queries, you can actually make sure that the SQLite database is using your index as you expect it to do. So the next thing, what was I going to show you next? So yeah, just to reiterate, before we go back to the slides, so at the bottom of my code here, so that's when I first launched the app, I created the database using my basic create table SQL. And then when I upgraded the database, we added this index on the latitude and longitude columns in that database. And then we could see the difference in the query execution time and the query plan that was being used. So if we go back to the slides. So why am I here? People have been asking. So the execute query plan, this is basically used to analyze your queries and gives you a sort of an overview of how the SQLite database is going to execute it. And it sort of specifically reports on which indices are going to be used to execute that particular query. Now, one of the things to note, there's a little asterisk at the end of my next statement. I won't go into what the asterisk is, but there's one particular use case where this statement isn't true. But each table in the from clause of a query can at most use only one index. So in this example bit of code we've got at the bottom here, you can see we've created two indexes on an example table, one on the column X and the other one on the column Y. And then if we do a select statement underneath on that table where X equals 5 and Y equals 6, it's only going to use one of those indexes. Now, it's up to the database which one based on various factors. So it might use the first index and find all the records really quickly that have X equals 5, and then it will scan those rows to find where Y equals 6. Or it might do the opposite. It might use the index to find all the Ys that equal to 6, if that's a sort of a smaller subset perhaps. And then it will scan those results to go and find the rows where X equals 5. So it's not going to use both indexes on this query. It's only going to use one or the other. So that's something to kind of keep in mind there. whilst trying to make my database quick for my app that I was working on, which was all to do with finding latitude and longitudes for pins in the database, I came across this concept called OurTree. And OurTree is a spatial index designed for doing range queries. So it's really tailored for latitude, longitude, geospatial kind of queries on your database. The really cool thing, or not, is that the Android version of SQLite doesn't have the OurTree module included by default. There is a GitHub, not a GitHub, a Android issue asking that to be built in, and it was marked obsolete in 2014, and it's still not in there, as far as I know. So the SQLite people have obviously got a nice wiki here on how you can build your own version of SQLite, something that we all want to do. And then, in theory, you can build your own SQLite version, include this OurTree module, and then if you're doing sort of heavy loaded work in the sort of the geospatial space, this is the kind of thing that you might want to be doing if you want to see huge kind of performance improvements on large numbers of latitude longitude queries. It involves building your own version of SQLite. It'll use the SQLite.org package name, not the package name of the one that gets shipped with Android. So you just have to change your kind of database helper includes to use the version that you've built, not the version that comes with Android. And then you should be fine. If you want some more info, just generic info on how SQLite does its query planning and the asterisk that I mentioned earlier on the one place where you can use more than one index on a query, it's all on this first page here to do with the query planner. Lots of really cool stuff on there about when indexes will be used and when they won't be used, when you've got greater thans and equals and all this kind of stuff. And if you're interested in the OurTree module, this is the link for finding out more about OurTrees and how they can be useful for geospatial queries. And that's it. That's all I had to kind of impart. Thank you.